So it's possible, but it will be hard to do, right? So we have symbols, some numerical columns, and timestamp. But I personally prefer schemas to be checked automatically. And yeah, I will show you what you can do with the code without schemas to convert it to schema code easily. Hello. Today I want to tell you about how you can make your pandas code more readable and generally make it more resistant to bugs in the future. In order to do that, you can add schemas to pandas data frames, and I will show you how you can do that. And for those of you who will listen till the end, there will be a bonus. I will show you how you can add schemas to the code that was implemented without schemas initially. So stay with me. And for me personally, when I switched from compiled languages like C# to Python, this thing with absence of schemas and type checking was a kind of big flaw. And I thought that it's just the evil that I need to tolerate. But in reality, there are pretty good things you can do to convert your code to quite similar thing to what you can do in C++ or in C#, but keeping all the advantages of Python. So let me show you this code example. In this piece of code, I convert price to a different format. So I normalize price of some asset on exchange and doing some transformations. And you may see that it receives data frame as an input and outputs data frame. It's quite a typical code that many data scientists and engineers write with pandas. And if we look inside, so I see that here we select some columns, we rename them, then we do some type transformation. It's not clear what was the initial type here. Then we do some more complex transformation with symbol. Basically what we do here is that we extract substrings from one string and then we convert timestamp and then we return the data frame. In reality, data frames transformation may be even more complex, like may take several screens of code. And if you read the middle of this code, it's really hard to understand, okay, what was the initial data frame? What were the columns? How have I transformed them? And the data here looks like that, the input data. So we have symbols, some numerical columns, and timestamp. And the problem with this code is that, yeah, first of all, it's hard to understand what is the input. But then, if I will make some modification or other developer will make some modification in the future, it will be hard to understand if the code still works as expected, haven't the developer broken something here. And yeah. And if you modify something in the input data, again, code may not notice it, or it may notice it in some deep place, and it will be hard to understand what actually caused error that you will see. Okay. And in order to make demonstration, I've basically written Python models. So this code is in this module, and I have a test for that. So I can write a test that loads some data and then passes it as an input to the data frame or to the function, and then checks the result with some simple check. And also here I have a code with schemas and test for code with schemas. And yeah, here is the data. And the code that I show you will be available on GitHub. I will put a link in the description, so you will be able to review it by yourself and try it. Okay, so now let's get back to this code. So what you can do it, what I did in the past to do some asserts to the code structure. So you may write something like that. It's pretty easy to understand and pretty easy to write, but I have many columns here, so I need to write many checks, or I need to write check with list that will look harder. Then if I want to assert on types, data types, I need to write more asserts here. So it's possible, but it will be hard to do, right? And let's see what you can do even better, right? So I will show you an example with schemas. So see, here when I write schemas, I have the same piece of code, but I have a decorator here, check types. I will show you later where is it imported from. Then I have a data frame with another type here, like row price, and then the return value is normalized price. And then the same piece of code that was previously, and it's returned. But what will happen is that when I will run this code, check types thing will check if all the schemas are correct, and if not, then it will raise an error, right? Okay, and now let me show you how this is implemented. So basically, this check types decorator is just imported from Pandera package, and these two types that I used for type hints are declared here. So I just declare a class that is inherited from schema model, and schema model is imported from Pandera, and then I write the structure as fields. This is basically the schema definition. So I say like what is the index and what are the columns in the data frame. So for example, this index is integer and it contains only unique values, and the same for symbol. And then I have like float 64 for price and for different fields, and then I have scrape timestamp, and in this case in the input it's string. And then I convert this schema to the thing that I will actually use using such a record. So I just take this data frame, which is also important from Pandera typing, and put this schema inside. So I have this type now, and I can use it in the type hint, and so that the type will be checked. And the same for the output. So I define the schema of the output, provide description here. So I use category types here. I use float 34 now, not 64, 32, sorry, not 64 here, and I convert timestamp, and the order is a bit different. Okay, and now when I write the function signature, I use these types, right? So that's what I do. And again, I have a test here to show you how it works. See? So again, this test passes, everything is correct now. And let me show what will happen if, for example, I will break data. So for example, some previous piece of code will drop symbol from the input file, or input data frame. So what will happen? I will see an error here, and basically it will say like, okay, error in check types, function like that, and column symbol not in data frame, and columns that are in data frame are like that. So error is super clear. I see what function failed and what is missing, so it's quite readable. So we'll commit it for now, or probably even drop. Okay, and yeah, this is quite simple example. So I just dropped the column, and actually both implementations would recognize that. But what if, for example, during the code modification, the developer in the future will modify this, for example, like write 2 here instead of 1. And let's see what will happen. I will do this modification in both examples. And in the case of code with no schema, there will be no errors. But in the case of code with schema, let's see what will happen. Again, yeah, again, function expected this. It's interesting. It says that the type is wrong, because actually I haven't dropped the initial symbol from here with schema. So I just reassigned. Yeah, I just reassigned the value. But so actually the error is even more interesting. But yeah, I recognized it here. It's great. And if I would drop, for example, symbol again, let's say we'll do like that. Yeah, then what will happen? Let me see. I will see an error again, but yeah, it would say that this column is missing. Well, it's expected by the schema. And in this case, you may say, okay, you can just add more lines of code in the task so that you will check that everything is present in the file. in the data frame? Yes, I can do that. But in this case, tests are just the simulation of what you will see in real life inside your pipeline, right? So it might happen that some previous piece of code just does something, some modification in the data frame that you don't expect, right? So and you can't check for that if you don't know that exactly this thing would happen. So we'll roll back this change. And yeah, what else could happen? So for example, something may change in the data, right? So let me open the data frame. And what I will do is I will just remove one value here so that the price is not filled for one row. And let's see what will happen with the code. The test with no schema just passes. It means that code will work and it will output the result with this value empty. And let's see what will happen with the schema. Yeah, so code with schema will recognize there's something wrong and will tell me, okay, so in this function, this column contains null values while it's not expected, right? And now I can either extend the schema if it's expected, or just drop values without with nonce, right? So for example, I can do like that. Oh no, actually no, it's expected. Okay, so it means that in the initial data, in the input data, it's expected. Okay, doing this in the wrong place. Let's go here. So it means that in the input data, I need to mark it as nullable, but in the output, I still will keep it as not nullable, and will do modification here. So I will drop values that contain none in price. Actually, when you do this, it's better even to do like that. Okay, and then check like that, and then do drop here. And do some error reporting. So it's also a really good practice to do that. And I will also provide some examples like that. So let's see how it works. Okay, something is still wrong. Oh yeah, and now I have dropped the row. Okay, so I need to check the test to modify the test. Super, yeah, it works. Okay, and in this case, I have put the schemas definition in the same place where I have the function. But in reality, it might happen that you need schema in different functions in different Python modules. Plus, such implementation is quite messy. So I have class, I have function here. It's hard to read, right? So what I usually do is I put schemas in a separate folder, and I will do this now. So what I will do is I will just copy schemas from here, and yeah, that's how you can easily do that. Row price schema. Okay, we'll do that. Sorry. Okay. So I have copied it with imports so that I can now easily drop not required imports, right? And I will do the same for the second one. So I don't need this anymore. Okay, have it here, and again we'll drop non-required imports. Yeah, great. And now what I will do in my code is I will just import schemas from there. And yeah, I probably will remove this schema from here. This schema word. Yeah. And we'll import from normalized price. Normalized price. Yeah, code is of the same size as before, and I have just moved the schemas definition to a separate file. So I will keep this for now. I can remove this from here. Yeah, so imports are also smaller now. And let's check that it works. Yeah, it works. And now, when I will look at the implementation, I will see this type. And in order to review the schema, I just, in PyCharm, I just do Control or Command on Windows, click on the type, and I get to the implementation. And then I press Command and square brace left to get back, right? So I can just easily navigate back and forth, right? And the same for normalized price, quite easy to understand. So if you read the code and you want to say, okay, what is in the output, right? So let's get back to here, click, Command click or Control click, and review. Super easy. And yeah, let me show what other checks can you do in the code. So for example, if I want to get here normalized price, so I already used this unique thing for the index to make sure that the index is unique. And you have seen that I can say that something is not nullable. So by default, for example, in the field, if I put nullable true, it's just how, oh, nullable false, sorry. It's just how it works by default. And if you want to make it nullable, you put nullable true here. But you have much more options available here. Let me show you. So you can check for equality, check for non-equality, greater, lower, is in, etc., 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 like many checks here. You can review them by yourself if you need. And if you don't need any additional checks, you just do a definition like that. And you can also add some custom checks. I will show you how I do that. It's also easy to do. So I have a custom check implemented here. That's what it looked like. So I just import this decorator register check method and define a function that, in this case, it checks series. So I just define it for series. And if in this case, I want to check that it's sorted ascending. So I just use some logic here to check it. And then in the schema, I do this. So you just need to import it once in any place. You can do this in some init file, but I import it in a schema usually, and just ignore that the fact that it's highlighted with gray. And then if we want to make sure that, for example, timestamp is sorted ascending, I'll do this. That's it. And now let's see what will happen with my test. It will fail. And yeah, it says that timestamp failed, fails this check, right? So quite easy to read. And what happens is that in the data, some of the rows are not sorted, and I will just add rows ordering in the implementation. So we'll go back to the implementation. And here, the place where I do some timestamp assigning, I write this will do assigning sorting. Let me check. Oh, no, that's wrong. Not like that. Something like that. Yeah, now it works. And yeah, that's what related to custom checks. And one more thing I want to show you is that you can check the schema to be strictly enforced. So let me show you what the data frame at the moment looks like. So in this case, I haven't let me see, price volume. Yeah, I haven't dropped this scrape timestamp thing, while it's not required by the schema. Let me show you the schema again. Yeah, so there is no this field, but I haven't dropped it, and the order is different. It may be not important, and if it's not important, just don't worry about that. But if you want to enforce the order and the structure of columns, you can do also easily enforce it like that. So you define config here and you say strict true. So all these things are described in Pandera documentation. And let me see what will happen. I will rerun the test. And again, I see that it fails, and the error, yeah, that some columns are not good. For example, scrape timestamp is not in the schema, right? And then again, you can, as you have the schema, you can do some cool and easy transformation with the data that will just reorder everything quickly. So how I do that is I have implemented some auxiliary method to get schema columns from the schema. So it's implemented here. And then I just reorder and crop columns with this and provide a schema normalized price. Right, let me see how it works. So it works now. Columns are reordered, and extra columns that are not needed are removed. Okay, and Pandera has pretty good documentation, so you can check it out. Okay. So you can read it through. Though I will show you their package on PyPy. Though they recommend, like as a default, they recommend usage of schemas like that. So when you define schema as an object, and then you validate the data frame explicitly. You can also do that if it suits your needs, but I personally prefer schemas to be checked automatically, like without any explicit call, because you may forget to trigger schema check, or if you add an additional parameter to a function, one more data frame, you may forget to check this one, and if you add the decorator, you will see that you will automatically check everything that you have here. So I prefer this way. But yeah, you can read through the documentation. It's quite cool. Everything is explained in details. And yeah, so I remember about the bonus. I will tell you about it in just a minute. Yeah, for now I will make an intermediate summary. You can use Pandera to add type checking for your pandas data frames. So it will make the code more readable. It will eliminate lots of bugs from modifications in the future, and you will just benefit from the efforts that you put into it. I recommend you to use it. But yeah, in reality, you may already have a code that has issues, and I will show you that doesn't have schema at the moment and has the issues that I told you about, and I will show you how you can work with that. And by the way, yeah, if you like this video, please press like and subscribe to my channel so that other people will also see it. And yeah, I will show you what you can do with the code without schemas to convert it to schema code easily. So what I will do is I will just, for example, do like that. Let's say I don't have a schema for the input yet, and I will actually like clean it, right? Just remove it for now. There's no schema at all, right? And let's see. My test will pass. I hope. Oh, probably no. What's wrong? Oh, yeah, I tried to import something probably from there. Yeah, so I don't import anything. Yeah, so I don't have a schema for input. In reality, you won't have schema for outputs also, but yeah, you will understand how to do that via the explanation I will give you. So what do? You need to somehow reproduce this function in the runtime. You might do this via test, or you can just debug your code with some production-like execution. And you put a breakpoint in the first line of code, and then you run it in debug. In my case, I will run the test and debug. And here I will have this data frame in variables, and what I can do is I can display its data types and show them as series, right? So here I have them, and then I create a file with schema, and yeah, go inside. Okay, no, I will create a file first. So let's imagine it was not created. So I create a file, I declare a schema like that, and then I just copy things from here. So I need index will be unique. So yeah, Copilot already helps me a bit with this. So I need index with unique. Okay, then what I do is I have last price, which is series with not float 34, but not float 32, but float 64. Then I have bid price, and I'll just copy it. Price, ask price, bid size, ask size, volume, okay, and scrape timestamp, which is string in this case. We'll write object or string. String will also work. Okay, so seems like I have copied everything from here. So I have this schema defined now, and I get back to the code, and now yeah, I import this and I put it here. And if you do this for the first time and there was no type checking, don't forget to add this decorator. Okay, so I stop the test and run it again. Something is wrong. Let me see what's wrong. Oh yeah, I haven't added this nullability, so we'll add it. True. Let's see. Yeah, it works. So that's it. I mean, it may sound really hard, like how can I add schemas to my code all over the project, but actually it's not that hard, and you will start to benefit from it from the day zero after you add it. So do this, improve your skills in pandas, and see you soon.